Hi students, welcome back to today's class. This is myself RK, IIT Maths faculty. Today I am going to explain how to find out the angle between line and the plane. See here, now I am going to explain how to find out the angle between line and the plane. See this one, this is the plane, right? So this is the normal of the plane. So wherever you take the plane always contain normal. Okay, na? Right. See, this is the 3D line. So the angle, this is the angle between line and the normal. Angle between line and the normal is nothing but angle between line and the plane. Okay, na? Right. See, this is actually plane. Okay. See here, ABC represents drs of the normal ray and also called drs of the plane also. Okay, na? Right. Now concept number 2. Here I am taking one of the plane equation and one of the 3D line equation. How to find out the angle between this plane and the line? We have one formula. Sin theta is equal to a1 a2 plus b1 b2 plus c1 c2 by square root of a1 square b1 square c1 square square root of a2 square b2 square c2 square. This is looking like cos theta formula. Okay, na? There cos is there, here sin is there. Okay, so angle means only theta. We don't want sin. Send the sin right and you will get sin inverse of above step. Okay, everybody remember this formula. So this is the formula to find out the angle between line and the plane. Okay, this is the concept number 2. Now come to concept number 3. This is actually I am taking plane. The plane will be in the form of two forms. This is the first form, this is the second form. This is the Cartesian form of the plane. This is the vector form of the plane. Okay, now in past classes we done the problems based on only Cartesian form. In upcoming classes then we have to solve the problems based on the vector form of the plane also. Okay, then when given the Cartesian form of the plane, how to convert it into the vector form, that I am going to explain. So suppose I am taking Cartesian form of the plane, how to convert this plane into the vector form. See, first you write r bar dot blindly. In step number 1 you write first, everybody r bar dot is common step. Then you copy this step as usual, but in the place of x, y, z, take I, j, k. That means 2i plus 3j plus 4k. Right, like that is equal to whatever the right side constant number you copy as usual. This entire step is looking like r bar dot n bar is equal to p, which is above form, also called as vector form. Okay, na? This is the way how to convert the Cartesian form of the plane into the vector form. Then come to concept number 4. So similarly take the 3D line. This is the Cartesian form of the plane line and this is the vector form. Now I am going to explain when given the Cartesian form of the line how to convert it into the vector form, that I am going to explain. For example, here see. For example, this is actually Cartesian form of the line. Now I am going to convert this Cartesian form into the vector form. How to write? You write yourself r bar is equal to 2 4 6, take it as a bar, means first bracket, plus lambda into, take the 3 4 10, means drs of the line in a second bracket. So this entire step is looking like r bar is equal to a bar plus lambda b bar, which is vector form of the line. Okay, na? Right. Now see concept number 5. This is the plane, which is vector form. This is the line, which is also vector form. R bar is equal to a bar plus lambda b bar. R bar is equal to a bar plus lambda b bar. Then when given the two vector forms of line and the plane, then what we have the formula to find out the angle between them. Sin theta is equal to n bar dot b bar by mod of n bar mod of b bar. Okay, na? So then you know how to find out the dot product of n bar and b bar. Okay, na? And you know how to find out mod of any vector. So that is already we learned in first year maths 1a. Okay, na? In next video then we are going to solve the problems based on the above concept. Welcome back to class. So students, now I am explaining to question number 1, problem number 1, which is based on the above concept. See, in 2005 AEEE one problem is given. If theta is the angle between this line, see here, this line is which form? Cartesian form. And the angle and the plane, this is the plane equation, this is in which form? Also in a Cartesian form, is such that sin theta is equal to 1 by 3, then find the value of lambda is set. Okay, now he is given Cartesian form of line and the plane is given, and angle between those line and the plane is given as sin theta is equal to 1 by 3, then what is the value of lambda is set. Okay, now that I am going to explain. Right, see, first you take the first plane you take plane. What is this is the given plane, na? This you compare with a1x plus b1y plus c1z plus d1 is equal to 0. So you will get a1 value, b1 value, c value, like as 2 minus 1 and root lambda. Then you take the given line, then you compare the given line with x minus x1 by a2 is equal to y minus y1 by b2 is equal to z minus z1 by c2. So that you will get a2 value, b2 value, c2 value. That means ds of the given line. Okay. Then you write the formula. What is the formula? Sin theta is equal to a1 a2 b1 b2 c1 c2 by root of a1 square b1 square c1 square root of a2 square b2 square c2 square. Okay, na? But he is given, but sin theta value is given as 1 by 3 in the statement. In the statement already he is given sin theta value. That's why I write in the place of sin theta, write 1 by 3. Okay, na? So whenever you keep all the values in this step, then we can get such kind of step. Okay, na? So here plus 2 minus 2 get cancelled, and you will get 2 into root lambda. Right? This will be 5 plus lambda with root. Okay, na? See this one. 1 plus 4 plus 4, na? So root 9. So root 9 will be 3. Then this will be root of 5 plus lambda. Okay. Then equal both sides cancel the like terms. So equal both sides cancel the like term. Then we have 1 is equal to 2 into root lambda by root of 5 plus lambda. Okay, na? Do it cross multiplication and you will get root of 5 plus lambda is equal to 2 root lambda. Do it squaring on both sides. Then you will get 5 lambda is equal to here 4 lambda. Why? Because this is actually we are doing squaring now. So 2 square will become 4, right? So root lambda square means lambda. Okay, na? So send this lambda right. That means minus lambda. So 4 lambda minus lambda, 3 lambda is equal to 5. Lambda is equal to 5 by 3. So which is the option here? Second option. Okay, na? This is given AEEE 2005. Now come to next problem. Second problem. In 2011 in AEEE one more problem is given. What is given? If the angle between the lines, see here also he is given line equation given in Cartesian form and plane equation given which is also in a Cartesian form. So here given angle as cos inverse of root of 5 by 14, then find the value of lambda. Okay, na? This is the question, right? This I am going to explain now. Look at that. Here first you take the plane equation and the line equation. Compare the plane equation with a1x, b1y, c1z plus d1 is equal to 0. So that you will get a1 value, b1 value, c1 value, like as 1, 2, 3. Take the line and you find out the a2, b2, c2 values by comparing the given plane with this form. Okay, na? So we have the formula sin theta, angle between line and the plane formula. Sin theta is equal to, this is the formula, right? Then keep all values here. Then I got like this 1 plus 4, 5, 5 plus 3 lambda by this will be root 14 and this will be 5 plus lambda square is equal to sin theta. So this is the value for actually what? Sin theta. But in the statement he is given the angle in terms of cos. What? So the given angle is cos inverse of root of 5 by 14. If you send cos inverse left and you will get cos theta. Cos theta is equal to root 5 by root 14. Then we know that one formula is there, na? Why? Because we want actually sin theta value. We don't want cos. But instead of sin, he is given cos in the statement. That's why I convert the cos in terms of sin. Okay, na? So this is the value of cos, na? If we know cos, we can find out the sin. How? We know that sin square theta cos square theta is equal to 1. So in this formula, keep this value and you will get 5 by 14. Send it right. 1 minus 5 by 14. If you take LCM, na, 14 minus 5. That is equal to, then here sin square theta is equal to 9 by 14. 9 by 14. Then sin theta is equal to 3 by root 14. Okay na? This is the value for sin theta. This is the value for sin theta. Give it's called equation number 2. Substitute equation number 2 in equation number 1. This is the equation number 1. In the place of sin theta, you put 3 by root 14. So if you do squaring on both sides, 3 will become 9. Here root will get cancelled. Okay na? So 5 plus 3 lambda whole square, which is looking like a plus b whole square. A square b square plus 2ab. So here root will go. So if you do cross multiplication, this step will come. So equal both sides you cancel. 9 into 14 into lambda square value, 9 into 14 into lambda square value. These both values we need to cancel. Then 630 is equal. So here this is the remaining step. This is the remaining step. This is the remaining step. In these both steps, so 14 is common. So take out the 14 common. 25 plus 30 lambda. Okay na? Then you cancel this entire step with the help of seventh table. 7 2 ja, and you write this 630 as 9 into 70. 9 into 70 630. Then you cancel this entire step with the help of seventh table. 7 2 ja, and 7 times ja. Again this 2 will go in this 10 up to 5 times. Okay na? Then 9 into 5 45 is equal to 25 plus 30 lambda. Send 25 left, 45 minus 25 20 is equal to 30 lambda. So send 30 left, so then 20 by 30 is equal to lambda. So the value of lambda is 2 by 3. Then what is the option here? So here option will be, this is the option 2 by 3, fourth option. Okay na? So based on these two formulas, yourself you try the third question. What is the third question? Find the angle between line and the plane. See here is given line in a Cartesian vector form. The given line is in the form of vector form, and also plane in the form of vector form. Okay na? So when given the vector forms, also we have formula to find out the angle between them, or else convert the vector forms in terms of Cartesian forms, then use the Cartesian form angle formula. Okay na? Yes, you try this problem yourself. Okay na? Right. Thank you, Ananda.